Welcome. In this video, we'll be talking about how to factor a monomial from a polynomial. So to begin, the word factor in math has two meanings. So the first one we've already encountered before, which is if I have 2 to the 5th power, what that really means is I have 5 factors, which is used in a noun in this case, of 2. Meaning I have 2 times 2 times 2 times 2 times 2. So factors means the numbers are multiplied together. Okay, so one way we use it is in a noun form, that we're referring to things that are being multiplied together. The other way we use it is as a command. So we say factor something. So in this example, the directions are to factor 40. Well, what that means is we're going to basically break 40 down into smaller factors, if possible. So this is actually an action or a command. And so what we're supposed to do is take our expression and somehow break it down using multiplication. So in this case, I could take 40, and I don't want to change the value of 40, but what I'm trying to do is to break it down into smaller pieces. So 10 times 4, it's still equal to 40, but now I've broken it down into smaller pieces. And then I could continue this process. So what we're going to be talking about in this particular section is something similar, except now instead of factoring just a single term, we're actually going to be factoring more than one term. So the first step in factoring is realizing what exactly we're trying to do. So basically our end goal, so if we look at number 1, where we're supposed to factor 20n to the 3rd plus 8n, really our end goal is to find two things that multiply together, two kind of smaller pieces that multiply together to give me this original expression. And so there's really a couple steps in the process. So the first step is to find the GCF. So if you haven't watched the videos on how to do this, go back and watch those videos, because it's going to be a crucial skill for being able to factor successfully. So in this case, our GCF, if I look at our two terms, we've got 20n to the 3rd and 8n. So again, I'm looking for the largest number that goes both into 20 and 8, and that is going to be 4. So our GCF is going to be 4. And then if I look at the variable pieces, I've got n to the 3rd and n to the 1st. So I take the lesser of the two factors, which is n to the 1st. So my GCF is 4n overall. So then step 2 is I'm going to rewrite each term as factors. So I've got 20n to the 3rd plus 8n. And what we just found out is that 4n is basically going to be able to be divided evenly into both terms. So if I look at the first guy, well, if I started with 20n to the 3rd, that means I can break that down into 4n times, well, 4 times 5 is 20. And then if I've got 4n and I started with n to the 3rd, that means I have to have 5n squared. The second guy, 8n, can be broken down into 4n times, well, if I started with 8n, 4n times 2 is going to give me 8n. Okay, so notice all I've done is I've taken our original terms and now written them basically in factored form. Okay, step 3 in the process is what I call the reverse distribute step. So what we're going to do is we're going to use the distributive property, but in reverse. So to prepare you for that, I just want to show you something. So if I have 3 times the group x plus 4, if I were distributing, what I would do is I take the 3 times the x, which is 3x, plus the 3 times the 4, which is 12. And I'm going to keep that as 3 times 4. So basically what we're going to be doing is the exact reverse of that. We're basically on this step, and what I want to go back to is this step with the parentheses and the group. So what went on the outside was actually this 3, which was being multiplied basically, which was a factor of each original term. So if I'm reverse distributing what we've got 4n times 5n squared plus 4n times 2. So notice that in each term we've got a 4n. So that's what's actually going to go on the outside of the parentheses is the 4n. And then what's left on the inside is basically what's left over from each term. So 4n times 5n squared, and then plus 4n times 2. And now let's make sure that we haven't changed anything. So we're actually done. This is the answer. But let's make sure we haven't changed anything. So step 4 is to check. So to check this out, what I'm going to do is take my answer and I'm going to actually use the distributive property and make sure that I end up getting what I started with. So 4n times 5n squared is 20n to the third. 4n times 2 is 8n. And that's exactly what I started with. So that must mean that my answer is correct. So going back to our original goal, what we just found out is that 20n to the third plus 8n can be broken down into 4n times the group 5n squared plus 2. Okay, so what I want you to notice is that I didn't use any mathematical trickery back here. Notice that both of these terms are still being multiplied by 4n. I've just written it in a slightly different way. I'm using the distributive property to write it as I did here. But it still means the same thing as it does back here, because when I have parentheses, that means each thing is still being multiplied by 4n. So I haven't done any mathematical trickery. Everything I've done is sound. Let's see if we can try another one. Okay, let's try number 2. So number 2, again, the first step is to find the GCF. And in this case, the GCF between 6n squared and 8n to the third, well, the largest number that goes into 6 and 8 is 2. And then we take the lesser of the factors of each variable, so that'll give me 2n squared. Okay, then step 2 is I write each as factors. So I've got 6n squared minus 8n to the third. So that must mean that 6n squared is going to be written as 2n squared times, well, this is the tricky part, is figuring out what's left over. So if I started with 6n squared, 2 times 3 gives me 6. And then since I already have the n squared here, and I started with n squared, that's all I really need. And then I've got a minus. And the 8n to the third can be broken down into 2n squared times, well, 2 times 4 gives me 8. And now I need to get 8n to the third, so I've already got n squared. That must mean I need an extra n here. Okay, then step 3 is the reverse distribute step. So I've got 2n squared times 3 minus 2n squared times 4n. And so again, what goes on the outside is the factor that these guys have in common. So in this case, they both have a 2n squared factor in common. So I'm going to throw that on the outside. And then on the inside, I just write what's left over, the things that were multiplied by 2n squared. Okay, then step 4 is the check step. So if I multiply this through, 2n squared times 3 is 6n squared. 2n squared times 4n is minus 8n to the third, which is exactly what I started with. So that must mean that this factoring is correct. Okay, I want you to try number 4, pause the video, and then restart it after you've given it a try. Okay, so for number 4, again, the first step is we need to find that GCF. So the GCF, well, 20 and 25 is going to be 5. And then b squared and y to the third, well, those guys don't have anything in common. So my GCF is just going to be 5. So that means that I can break each one of these guys down into 5 times something. So the first one is 5 times 4b squared minus 5 times 5y to the third. And then the next step is the reverse distribute step. So notice again that both terms have a factor of 5 in common. So I pull that outside, that goes outside the parentheses, and then the inside is what's left over, which in this case is 4b to the second minus 5y to the third. And now all we have to do is check this. So 5 times 4b squared is 20b squared, that's what I started with. 5 times negative 5y to the third is negative 25y to the third, which is what I started with. So this is my final answer.